Have you ever wanted to go to space, travel to Mars, be the first person to set foot in an unknown place like Neil Armstrong? Well, right now, with our knowledge of space, we know that Armstrong was lucky he didn't come back from the moon with severe radiation poisoning. See, that's the thing. Space is full of radiation and funky magnetism phenomena. There's cosmic radiation, which is radiation that comes from other stars that are solar system and galaxies away. There is also solar radiation, which is what would harm any astronaut that goes to the moon today. Solar radiation can come in many forms, including coronal mass ejections and solar flares. Needless to say, solar radiation comes from the sun. Solar flares are caused by changes in the sun's magnetic field, which, when extended out into the planetary region of the solar system, is known as the interplanetary magnetic field. See, the sun has a cyclical lifestyle, so when it hits solar maximum, the greatest amount of solar flares, or magnetic storms, are sent out into the solar system, or the interplanetary magnetic field, along with lots of solar radiation. When we are not in solar maximum, so in solar minimum, lots of cosmic radiation comes into the solar system, even though there's not many solar flares. So, while the magnetic storms come and go in an 11-year cycle, the radiation always stays constant. Now, see, here on Earth, we're relatively safe from all of this space radiation, solar flare stuff. We have our own magnetic field that acts as a protective bubble around our planet, which is great and all for all minor radiation and magnetic storms. But when there is a huge solar storm, that is when we, as humans, with technology, run into problems. The magnetic fluctuations can cause errors in GPS satellites, which really only causes people to get lost. They can also mess up the connection of cell phones, which is more of an inconvenience than anything else. But they can also take out transformer grids, which are what we use today to power basically everything. Think about it. If a magnetic storm is severe enough, we are sent into a world without any technology. So, how can this world protect itself from going into the dark ages of technology? Well, I have created an answer for everyday people to get a glimpse of what is going on with space weather so that they have a little bit of time to unplug their electronics so that they don't get fried in the event of an extreme solar flare. I built a homemade magnetometer, which is a device that measures the changes or fluctuations in the Earth's magnetic field. Alright. I made this magnetometer with a penny, a jar, 2 neodymium magnets, fishing wire, 2 tiny mirrors, and an index card. Basically, I mounted them like this. The magnets rotate with every fluctuation in the Earth's magnetic field that they detect. The penny and the index card just dampen the magnet's movements. To actually get a visual representation of these movements, a laser was shined onto the mirror, which in turn reflected the light onto the wall. The further the light moves across the wall, the more magnetic fluctuations are being detected. Now, obviously you're thinking something along the lines of, cool, does it really work? Well, I can assure you that it does. When the data recorded on the light fluctuations was compared with the data from the National Oceanic and Atmospheric Administration, or NOAA, which is the government's space weather forecasters, there was a correlation between higher solar activity and bigger light movements across the wall. So what really happened to my TV earlier? Well, a solar flare occurred and the excess solar activity blew a transformer near my house, so the TV was shot. The solar flare caused a lot of magnetic activity near the sun. If I want to prevent my next TV from getting blown out, I should probably make a homemade magnetometer so that I can predict space weather and unplug my electronics in time.